Hi, and welcome to today's SFP webinar on maximizing installation flexibility and storage capacity using ESFR sprinklers. This is Louis Garazzi, SFP's Director of Professional Development, and I'll be moderating today's webinar. Before we get started, I'm going to go over some information in regards to the webinar logistics. First, all participants will receive a certificate of attendance for 1 PDH. To receive a certificate, you must stay online for the entire webinar. Certificates will be sent out via email within 1 week. Also, we do not provide copies of the speaker's PowerPoint presentation. However, we will be posting a video of this presentation on the SFP's YouTube channel and website in the next week. Additionally, you can ask our speaker questions by writing it in the webinar dashboard. You may ask a question at any time. However, we will not be taking any questions until the end of the webinar. Today's speaker is Manny Silva. Manny is the Chief Engineer and Fellow for JCI's Fire Suppression Products business. He has over 30 years of engineering experience, and for the past 20 years, he has developed numerous products for use in fire sprinkler systems and is named on 30 US patents related to fire suppression devices. In his current role as Chief Engineer, Mr. Silva is involved in the research and development of new fire protection products and is a member of a technical committee covering NFPA 13, sprinkler system discharge criteria and sprinkler installation, NFPA 30B and NFPA 1925. So with that being said, please welcome Manny.
Thanks, Louis. Thanks for the intro. And it's great to be back here conducting an SFP webinar. I want to thank everybody for attending. And I'm hopeful that you'll get something useful out of this presentation. So today's seminar, I'm going to focus on storage applications, in particularly fire sprinkler protection schemes used in warehouse and storage applications. So unlike just occupancy type protection, warehouse protection has a lot of challenges, and I'm going to go through quite a bit of those. And today we're going to focus on a couple of key attributes with regards to fire sprinklers. And particularly, we're going to talk about ESFR sprinklers, early suppression fast response sprinklers, and their placement within the building, in particular, where the sprinklers are located relative to the ceiling. And we'll also talk about protection schemes and how ceiling heights and aisle widths have an impact on storage volume that you can put into a warehouse. And overall, we'll look at how sprinkler selection impacts both the ceiling to distance as well as aisle width distance to maximize flexibility and storage capacity within a warehouse. So storage facilities, as I'm sure most of you on this call know, present extremely challenging fire scenarios. Those of you who are familiar with NFPA 13, standard for designing and installing fire sprinkler systems, NFPA 13 essentially looks at two different types of applications. One I would call occupancy applications, and then warehouse applications or storage applications. Occupancy applications, as you know, are things such as occupancies are give you your hazard classification, whether that occupancy is considered light hazard or ordinary hazard or extra hazard or potentially residential. And sprinklers that are used there are traditionally called controlled mode density area sprinklers, or CMDA, and those systems are designed using area density curves. You figure out what your occupancy is and your hazard, and then you can determine what your hydraulic requirements is based on the area density. Storage facilities get a whole bunch of chapters now in the NFPA 13 document. In fact, if you're now familiar with the NFPA 13 2019 edition, you're aware that the storage chapters have been completely rearranged. Previously, prior to 2019, NFPA 13 had, it showed the storage applications based on both the type of storage arrangement and the type of commodity being protected. In 2019, there was a significant change made where now the storage applications are broken down by the type of sprinkler. So there's a chapter for the CMDA applications. There's a chapter for control mode specific application, or CMSA sprinklers, and there's a chapter on ESFR, early suppression fast response sprinklers. And I'll get into that in a little more details. So storage facilities, as I said, have lots of challenges. Right? You have three-dimensional fires. They're side to side and they go up. And warehouses, they're built to store things, and they can store just about anything. And they can be rather tall facilities. So fighting fires that can be over the heads of firefighters can be extremely challenging. Depending on the ceiling height, it can also be very challenging for the water to get from higher up on the ceiling down to the floor, down to where the fire is located, and be able to address it adequately. And there's so many types of storage configurations and types of commodities that could be into a warehouse. It makes these very, very challenging scenarios. So figuring out what type of sprinkler or fire protection system to use is extremely important. So I mentioned things like commodity. So when I mentioned occupancy type protection schemes that are in NFPA 13, extra hazard or light hazard or ordinary hazard type occupancies, when you're designing for storage applications, obviously the first step, one of the early steps, is at least to identify what commodity you have. Storage protections, are driven by the commodity and the challenge of protecting that commodity. So you could have things that would be considered somewhat innocuous, like class 1 commodity, which is essentially things that don't burn, which unfortunately you don't find too many warehouses that are just class 1 commodity. And then as you increase along the hazard classification, you start to increase the amount of combustible material. So as you go from class 1 to say class 3, you start to increase the amount of plastics that get involved to the point that you jump from the class 1, 2, 3, 4 all the way to group A plastics. And then the plastics themselves offer a tremendous amount of challenges to an effective fire sprinkler system due to the heat release rate that's generated. And so you have to know what is your commodity classification? Do you have plastics? How much plastics? Is it cartoned? Is it uncartoned? Is it expanded plastic? Is it unexpanded plastic? Is it encapsulated or unencapsulated? So this is all basic information that's required in order to effectively design a fire sprinkler system for warehouse challenges. So why do we want warehouse fire protection? Well, we don't like it when things burn down. And so the fire protection scheme, first and foremost, has to provide effective fire protection, right? And so, but to go along with that, other items that we're looking to do with fire protection for warehouses, we like to maximize storage capacity. Why? Well, the more that can be stored within a warehouse is likely going to drive how much money a warehouse operator can make off his facility. The more goods that go in and then get out offers opportunities to generate more revenue. Secondly, operators want flexibility. What goes where? We like to minimize having restrictions on where exposed expanded plastics can go, or even if you can have exposed expanded plastics or things of that nature. If you can have flexibility, the chances of something going wrong get significantly reduced. And then this type of storage arrangement. We'd like to be able to move racks as needed, as business conditions dictate. Flexibility in whether it's on the rack or palletized or high piled or stacked. I also want to minimize the risk of damage and disruption. When a forklift hits a sprinkler that might be in a rack, no one has a good day. So a significant goal that we have with warehouse fire protection is developing ceiling-only protection. All right, so I'm going to get into a little bit about rack storage arrangements. So racks, you see some slides there. There are essentially 3 different types of racks. in general. So single row rack is just one row of an open rack. They do not typically have solid shelves, and you store pallets on them. So with single row rack, you have one rack that's essentially the width of a pallet, and they're separated by aisles. A double row rack, as you see in the diagram, shows two single row racks that are back to back, and then they're separated by an aisle. And then if you have more than a double, then you get into multiple row racks. So each one offers challenges with regards to fire protection schemes. And a lot of my presentation will focus on rack storage arrangements and the effect that sprinklers will have on how many pallets can be stored on the racks. I actually talk about how many racks you can actually fit into a space, and therefore how many pallets you're able to store. Obviously, there are different storage arrangements that are also in warehouses. I mentioned solid piled, things stacked right on top of each other. Palletized, which is pallets of goods stacked on one another. Bin box storage arrangements. Shelf storage. Racks are not shelves. Shelves get their own definition in the fire protection standards. So you have standard short shelf storage as well as back-to-back shelf storage. So as with commodity selection, it's important to understand the type of storage arrangement, as the combination of commodity as well as storage arrangement will dictate the type of fire protection that's required. A very important attribute to successful fire protection is having sufficient flue spaces. So flue spaces are essentially the spaces between the rows of storage. And there are longitudinal flue spaces that are perpendicular to the direction of the loading, and transverse flue spaces that are parallel to the direction of loading. And obviously vertical flue spaces. So why are these important? Well, in order to have effective fire protection, particularly with ceiling-only fire protection, it's important that the sprinklers operate as quickly as possible after the fire event has occurred. And so the flue spaces, as the name implies, allow heat to rapidly rise vertically to get to the ceiling. That heat gets to the sprinklers, and then the sprinklers able to operate. And then the second phase is that we want the water that's being discharged from the sprinkler to cascade down and penetrate the rack to address the fire. And those open flue spaces provide the passageway for water to travel down to the fire. So appropriate flue spaces are important when using ceiling-only fire protection. I mentioned aisles, which is the space that's between the racks, whether it's a single row rack or a double row rack. Walking or having equipment move between the racks requires an aisle. And aisles are obviously very important with regards to how many racks and how much storage can be put into a warehouse space. Things that dictate the width of the rack, width of the aisle rather, would include how much space is needed to move the commodity, but based on the commodity size itself, as well as handling equipment, whether it's a forklift or other type of lifting equipment that's used to store and retrieve the storage commodity. So let's get into sprinklers, storage sprinklers. As I mentioned in reading NFPA 13, there are 3 chapters that cover the 3 types of storage sprinklers. Control mode density area sprinklers, control mode specific application sprinklers, and suppression mode sprinklers, or ESFR. So for many, many years in the fire sprinkler industry, the only type of sprinkler that was essentially available is a control mode density sprinkler, or CMDA. These are currently used, as I mentioned, in non-storage applications, in the occupancy type of protection schemes, and were the first sprinklers used for storage applications. And typically, they're based on an area and a density. In the sprinkler world, density is the gallons per minute per square foot that is discharged through a sprinkler. So if a sprinkler was protecting 100 square feet, and you're discharging 20 gallons a minute, that's about a 0.2 density. So just a quick example for you there. So chapter 21 now in NFPA 13 2019 edition provides protection schemes for CMDA type sprinklers. FM 8-9 also has CMDA applications as well. Typically, the CMDA, depending on the commodity classification as well as the storage arrangement, can get just ceiling only protection up to about 30 feet. And there's examples of some CMDA sprinklers, 11 K factor sprinklers. There are 14 K factor sprinklers available, 16.8 uprights and pendants, and K25 extended coverage sprinkler, as you see there, upright sprinkler. There's also a pendant that can be used as CMDA sprinklers per NFPA 13. Control mode specific application sprinklers, or CMSA, I believe started to come about in the early 70s. The first one may have been the large drop sprinkler. And this sprinkler protection for storage applications is different. It's not based on area or density. It's essentially based on, the hydraulics designs are based on number of sprinklers at a defined pressure. So if you go to chapters 22 or 24 of NFPA 13 2019, you'll see protection schemes for CMSA application sprinklers, and they'll focus on the number of sprinklers and pressure based on the commodity classification, storage arrangement, as well as the ceiling height and storage height that the sprinkler is going to protect. So you might see a protection scheme that calls out 15 sprinklers at 25 psi, or 10 sprinklers at 40 psi. So we're not concerned about the area. The insulation requirements for CMSA sprinklers specify the maximum distance and minimum distance between sprinklers, which essentially defines the area that sprinklers can protect. But the hydraulics are only based on numbers of sprinklers at a defined pressure. And looking at protection schemes for CMSA sprinklers, again, depending on storage arrangement and commodity classification, you could have protection schemes of ceiling only up to about 40 feet in height. Suppression mode sprinklers, ESFRs, early suppression fast response, developed in the late 80s with the K14 sprinkler. The K25 sprinkler launched in the late 90s. And then through the 2000s, we've seemed to have added quite a bit more K factors, 16.8, 22.4, and over the last year, K28, and then very recently, JCI launched a new ESFR 34 sprinkler, or K33.6 sprinklers. So the ESFRs essentially offer the fire protection schemes with the highest ceiling only allowances. So again, like the CMSA sprinklers, ESFR sprinklers, hydraulic designs are based on a number of sprinkler at a defined pressure. You can see the protection schemes in chapter 23 of NFPA 13 2019 or FM 8-9. And now there are protection schemes available using ESFR sprinklers all the way up to a ceiling height of 55 feet, again, depending on storage arrangement and commodity classification. So since, over the past 30 years, there's been a substantial increase in ceiling only protection schemes through the use of both CMSA and ESFR sprinklers. Now, you might be saying, well, why do I always want ESFR sprinklers, or what's the benefit? I'm sorry, ceiling only protection. What's the benefit of ceiling only protection? Because there's an alternative thing you can do if you want to have good fire protection, and that's you could use in-rack sprinklers. So in-rack sprinklers, as the name implies, are taking sprinklers and installing them right within the racks. And there are a significant amount of schemes available using in-rack sprinklers, both in NFPA 13, which now actually has a whole chapter, chapter 25, dedicated to in-rack protection schemes, and FM 8-9 also offers some alternative protection schemes as well. And in-rack sprinklers offer very effective fire protection. Obviously, they'd be much closer to the fire source than ceiling-only protection, so the fire will be much smaller when the in-rack sprinkler operates. And typically, the hydraulic requirements are less since the sprinkler is closer to the fire is smaller. You're able to address a fire in the rack with less water than ceiling-only protection. However, no one seems to like in-rack sprinklers in terms of the warehouse operators. Through the years, I've talked to a lot of people running warehouses, and what they tell me is you got to get these sprinklers out of the racks. They're susceptible to damage. They take up storage space. I can't move my racks easily. Got to get these sprinklers out of the racks. And that's been the driver for the past 30 years in the development of CMSA and ESFR sprinklers, is listening to the customers who are operating warehouses and begging us, imploring us to find protection schemes that take sprinklers out of the racks. Okay. One of the attributes with regard to sprinkler installation is putting the sprinklers, somewhere up in the ceiling. That's why we have there's a lot of installation rules. So if you go to NFPA 13, the installation chapters talk about where these sprinklers are located, how they get located relative to obstructions. You walk into a warehouse and you look up, there's a lot of things on that ceiling besides just sprinklers. Me as a sprinkler guy, I want to walk up there and I just want to see a clean line of sprinklers and everything out of the way, but that's not always the case, right? So there's ceiling structure up there. There's beams, there's girders, there's purlins, there's vents, there's ductwork, there's heaters, there's air conditioning units, there's lights, there could be fans. So there's a lot of different things up on that ceiling. And unfortunately, you have to make sure that the sprinklers are placed in the proper location to minimize the impact on response time as well as spray distribution. As I mentioned, the sprinklers respond to heat. And if the heat doesn't get to a sprinkler, it's not going to operate the sprinkler. And when the sprinkler does operate, it's important that the spray distribution not be negatively impacted by any obstruction that's close to the sprinkler, so the water ends up where it's supposed to go, down below the sprinklers. The original ESFR sprinklers, the K14s, were approved with a ceiling to deflector distance of 14 inches. When the ESFR 22 and 25 came along, they were able to increase ceiling to deflector distance to 18, or just make you aware, the FM standards actually measure sprinkler location not to the deflector, but to the center line of the thermal element. So when you read, say, FM 2-0 or 8-9, it talks about sprinkler location, you'll see ceiling to thermal element distance of 17 inches for ESFR 22 and 25, as opposed to 18 from NFPA 13, which talks about ceiling to deflector. So there's a little difference, but essentially, based on sprinkler dimensions, they're pretty close. And NFPA 13 states that sprinklers with the K factor of 22.4 and 25.2 shall be positioned so that deflectors are a maximum of 18 inches and a minimum of 6 inches below the ceiling. So going from the 14 to the 18, we increased the distance by about 4 inches or so. And that's actually pretty significant in dealing with what's on the ceiling. So the pipes on the K25 and 22 can be lowered if needed. The sprinklers can be lowered if needed or moved around with greater flexibility. And that, a few inches may not of the trades, having as much flexibility or having any flexibility is a good thing. So as I mentioned, NFPA 13 measures the sprinkler from the ceiling to the deflector. And if you look, just about all the ESFR 25s, I'm sorry, all the ESFR 22s that you are listed for NFPA 13 applications have a ceiling deflector distance of 18 inches. There are some sprinklers, ESFR 25s, that are approved only with the 14-inch ceiling to deflector distance. Others have the 18. So, my point is that not everything is the same. You need to understand which product you have and make sure you understand what the approvals and listings are for that specific product that you want to use, because not everybody's is the same. And so you just need to be very careful in understanding what you're using and how you're using it. So for instance, ESFR sprinklers, in addition to being approved to a 45-foot ceiling in NFPA 13 FM8-9, a number of sprinklers, there's an ESFR 22, the Tyco ESFR 25, and an ESFR 28, which have UL specific application listing with under a 48-foot ceiling. But one thing you should note is that at that ceiling height, all these three sprinklers are only approved to the 14-inch deflector distance. So I'm pointing this out to make you aware that the applications will drive some of the installation requirements for the sprinklers. So it's important. I can't reinforce this enough. It's important to read the literature that comes with the sprinklers to make sure that you're installing them properly. As I noted previously, FM measures the sprinkler location from ceiling to center line of thermal element. And I have a chart here that's taken from the latest edition of FM 8-9. And you can see that FM 8-9 in this particular table focuses on ceiling heights of 50 and 55 feet. FM has approved protection schemes with ESFRs 22, 25, 28, and the 33.6 at 50 feet, and has a couple of protection schemes with the ESFR 28 and JCI's new ESFR 33.6 sprinkler at 55-foot ceiling. And so looking at the column that's highlighted in blue, you would see that depending on the sprinkler type, there are differences in the distance from ceiling to sprinkler's thermal element, which can be pretty significant. Like, so for instance, looking at the ESFR 25, the K25.2, you can see that there are actually two different allowances for the ceiling, the sprinkler to ceiling protection distance. You can have a 13-inch distance, but that's with the hydraulic design of 10 sprinklers at 50 psi. If you want the additional 4 inches of flexibility, that actually requires an increase in hydraulic pressure to 75 psi. So in this scheme, it's important to note that, yeah, you can have the 17-inch ceiling to thermal element distance, but you have to make sure that you're designing your system for 75 psi. So even within a height, the same sprinklers, and this is appropriate for all manufacturers of ESFR 25. Each sprinkler will have there are different potential distances for the same sprinkler, and you have to be aware that there's an potential impact around that. At the 55-foot ceiling where there are 2 sprinklers listed, you can see the ESFR 33.6 has a distance of 17 inches. The ESFR 28 is a distance of 13 inches. So again, you have to understand the specifics around the products that you're using. So in summary, the distance from the ceiling to the sprinkler is measured differently between NFPA 13 and the FM data sheets. And so it's important to understand which requirement you're using and be sure that you're measuring the sprinkler appropriately. Ceiling heights affect the allowed ceiling to sprinkler distance. Sprinklers listed and approved for the same ceiling height may have different listed and approved ceiling to sprinkler distances. And the maximum installation flexibility can be achieved by selecting sprinklers that have the maximum listed and approved ceiling to sprinkler distance. So, all right, let's talk about another interesting attribute when it comes to ESFR sprinklers, and that is the attribute of aisle width. So I mentioned that aisle width is the distance between the racks, and like sprinkler to ceiling distance, it's impacted by the ceiling height and the type of sprinkler. So going up to 45-foot ceiling protection, essentially all ESFR sprinklers, whether FM approved or per NFPA 13, have the same aisle width allowances. So essentially, I believe 3.5-foot aisle is the minimum that's allowed up to those ceilings. Typically, we look at a 4-foot aisle for 45 feet ceiling and below. However, once you get above 45 feet, all bets are off with regards to the aisle width. So for instance, I mentioned that there are different sprinklers that are have a UL specific application listing to 48-foot ceiling. And all 3 sprinklers have different aisle width approvals. So for instance, the ESFR 25 that Tyco manufactures / JCI, our 45-foot listing is with a 5-foot aisle. The ESFR 28 is listed with a 6-foot aisle, and there's an ESFR 22 that also has the UL specific application listing, and that has an 8-foot aisle. So again, even though the sprinklers are approved to be used at a 48-foot ceiling, and even though, as I mentioned earlier, these same 3 sprinklers have the same ceiling to deflector distance of 14 inches, now they have different aisle width allowances, which is again critical to ensure that you're using the product correctly. When you get to 50-foot approvals through the FM data sheet, all the ESFRs that are approved by FM when you get to 55 foot, there's again a difference in the aisle width approvals. The ESFR 28 is approved with an 8-foot aisle, and is approved with a 6-foot aisle. And I'm going to talk in detail about what impact that has on storage capacity. So I came up with a method of trying to figure out how much you could put into a warehouse. Now, this is a rather simplistic look and makes quite a bit of assumptions. And I'm going to go through with the assumptions, but it's a method I came up with to figure out kind of an apples for apples comparison. Assuming that you had an area in a warehouse that you're going to put your storage, and regardless of the protection scheme you're going to pick, the area was going to stay the same. So in the figure that you see here on the left, I have a plan view of a warehouse space. And this warehouse space has this bottom dimension, what I call building dimension A, which is perpendicular to the racks, and dimension B, which is parallel to the racks. So assuming that dimension A and dimension B is the available space within a warehouse that you could put all your storage, my analysis is focusing on that area. And I made an assumption that, within this space, there's going to be at least a 4-foot clearance between the racks and whatever is beyond, whether it's a wall or the space that's not occupying. But you're going to have a 4-foot clearance. And then looking at the plan view of the racking scheme, I assumed that we had a double row rack, and my double row rack example is 7.5 feet or 2.3 meters, because that's typically what I've seen, at least particularly when I do the testing at both UL and FM. It's about 7.5 feet wide. And then, my standard pallet, the 42 by 42 inch pallet. And with this example, these are the standard dimensions that I use. Again, I had to establish a baseline for my example, and this is what I picked. Obviously, there are other things, other dimensions, but as long as the only variables that we're changing are things like storage height and aisle width, we could pick any of these dimensions, and the outputs would essentially be the same. So came up with this great formula a set of equations for figuring out how much storage you could have in a warehouse. Now, since this is a webinar sponsored by the Society of Fire Protection Engineers, I'm going to make the bold assumption that there are lots of engineers on the call, and higher mathematics of multiplication and division is not an issue with you guys, with all. So at the end of the day, my warehouse capacity example is based on the total number of pallets that can be stored. And so basically the total number of pallets is based on how many double row racks can fit into a space. So here on the left, you see double row racks. So I need to calculate how many of these I can fit given my dimension A. And that's going to be based on the actual width of the double row rack plus the aisle width. I need to figure out how many tiers I have, which is the vertical storage of the pallets. And I'm assuming that a tier is about 5 feet in height. And I need to know how many pallets I can have in linear foot. So in this example, this double row rack is 25 feet long. I can fit 12 pallets. So for every linear foot, I can fit half a pallet. So this is my equation that I've come up with to determine total number of pallets. If you have any questions on it, feel free to write me. It's as my calculus teacher used to say in college, this is basic algebra. You should know this by now. So not exactly higher mathematics, but it does the job. So what does this mean? So here's a couple of examples with 35-foot ceiling with 4-foot aisles and 35-foot ceilings with 5-foot aisles, and also looking at different storage heights. So 35-foot ceiling, go through here's the example of the calculation. So with a 35-foot ceiling, with a 4-foot aisle, so 30, which is 30-foot storage, 30 feet of storage, 4-foot aisle, going through the calculation, I can theoretically, in my space that's 200 feet by 200 feet, or 40,000 square feet, I can fit close to 9,800 pallets. When I run the same calculations with a 5-foot aisle, I lose about 6% of the capacity. You can see the diagrams below kind of show the impact that the aisle with. The aisles are the gray area, and the double row racks are the white area. So you can see in a 200-foot space, I actually lose the ability to store one whole rack of material, which is in this case about 6%. If I reduce the storage height with the same 4-foot aisle, I actually reduce the amount of storage by about 16%. And then if I again add the 5-foot aisle, I go down again another 6 or so percent. So in this example, storage height actually has more impact than aisle width, but that's not always the case. So let's compare the 40-foot ceiling with the 45-foot ceiling. Again, this is where everyone has essentially the same approved sprinklers with the 4-foot aisle width. You can see there's a significant increase in the amount of capacity just by adding the extra tier within this space. So the about 13,000 pallets could be stored in this space. However, as I noted, once you get above 45-foot ceilings, things change. The approvals, as I showed you, have different aisle widths, and it's a lot more challenging to have successful ceiling-only protection at those higher ceiling heights because it takes longer for the sprinklers to operate, which means there's a bigger fire to deal with, and we have an increased chance of skipping. Skipping is a phenomenon where a spraying sprinkler will discharge its water, and the water somehow gets negatively impacted by the fire plume and starts wetting the surrounding sprinklers and either delays or prevents the surrounding sprinklers from operating. And when skipping occurs, the chances of having a successful fire test are very low. And the higher the ceiling heights, the increased chances of skipping. Commodities can have a big impact on fire growth. Exposed expanded plastics and exposed unexpanded plastics are very different commodities relative to, say, cartoned unexpanded plastics. Exposed expanded plastics has very fast fire growth. Those fires run away quickly. Exposed unexpanded are slow growing, but boy, once they finally do get growing, they're really hard to put out with that heat that's generated. So aisle width plays a major role with higher heights and more severe commodities, also because of aisle jump. Aisle jump occurs when the fire from the main array jumps across the aisle and ignites the target arrays in these fire tests. So all of these contribute to making it much more challenging to get ceiling-only fire protection at higher ceiling heights. So, as I mentioned, there are sprinklers approved at a 48-foot ceiling, the specific application listing. So this chart compares the amount of storage you can have at the different ceiling heights and different storage heights between a 48-foot ceiling with 43 feet of storage and a 45-foot ceiling with 40 feet of storage. As I noted, the Tyco ESFR 25 is approved with a 5-foot aisle. And what's interesting is that with the 5-foot aisle at 43 foot of storage, you can essentially have the same amount of storage capacity within the area as the ESFR 25 and 22 does with the 40 foot of storage height with the 45-foot ceiling. When you look at the different aisle widths that are approved with the 48-foot ceiling, you can see with the 6-foot aisle width, there's a reduction of about 6% capacity, and with the 8-foot aisle width, there's about almost a 19% reduction in capacity. So just changing the aisle width allowance has a significant impact on how much storage, how many racks you can put into a warehouse, and how much storage is allowed. So let's look at the 50-foot ceiling approval. So as I noted, FM now has ESFR approvals with the 50-foot ceiling, and all of those approvals are with a 6-foot aisle. So looking at the FM approval with the 50-foot ceiling and a 45 feet of storage and a 6-foot aisle, you have just under about 13,000 pallets that can be stored. And again, looking at the example with the 45-foot ceiling and the 40 feet of storage, 4-foot aisles, you actually have slightly more, or essentially the same amount of storage is there. So from a storage capacity standpoint, there's potentially not a lot of benefit if your arrangement allows you going down to a 4-foot aisle. Obviously, at these high ceiling heights, there are certain challenges with regards to aisle width because the equipment that you're using may require an aisle that's greater than 4 feet. But if you have the ability to minimize your aisle width, get it as close to 4 feet as possible, you can certainly maximize your storage capacity. Again, looking at the 45-foot ceiling, as I said, with the 6-foot aisles, and then let's look at the 55-foot. Oh, sorry, I went back. So the 48, so similar to the 45 at 50, essentially the 48 versus 50 is the same. As I noted previously, the number of pallets that can be potentially stored under a 48-foot ceiling and 43-foot storage with a 5-foot aisle is essentially the same as the 45-foot storage arrangement. And so, so again, these are opportunities where you can maximize your storage by understanding what the approved aisle widths are for the different sprinklers at different ceiling and storage heights. And when we look at the 55-foot ceiling with the 6-foot aisle approval, so as I noted, Tyco has recently launched an ESFR 34, which is FM approved, and it has a 9-head design at 55 PSI and approved with a 6-foot aisle. So with this particular sprinkler, even with the 6-foot aisle, you're able to significantly increase the potential for storage over all the other schemes at the different heights, the 50-foot ceiling height, the 48-foot ceiling height, as well as the 45-foot ceiling height. So the current protection scheme with the maximum potential capacity for storage is the ESFR 34 at the 55-foot ceiling, which is approved with the 6-foot aisle. The other sprinkler approved at 55 foot is approved with an 8-foot aisle, As you can see from the calculation, there's a it's a reduction in the amount that you can store. Again, at these ceiling heights, there are certain challenges about how narrow you can make your aisles based on the commodity being stored and how that commodity is being stored in, added and retrieved from the storage racks. But to maximize the potential for storage capacity, finding the sprinklers that are approved with a minimum aisle width will give you the most potential for maximizing the storage. And this last table just provides a summary. As I noted, my example focused on a building warehouse area that was based on a 200-foot dimension along the width of the rack. And I did a 200 by 200 example of 40,000 square foot example, which was this line here. All of the scheme that again has the potential for the highest value of number of pallets that could be stored is the 55-foot ceiling approval with the ESFR 34 and 6-foot aisles. So in summary, aisle width has an impact on storage capacity, and based on the aisle width, the ceiling height does not always mean potentially more storage. The aisle width can actually drive storage capacity more than the storage height or ceiling height. Ceiling heights that are greater than 45, as I said, have more impact than the storage height, and choosing the right sprinkler or choosing a sprinkler will impact the storage capacity of the warehouse. So in summary for today's presentation, the two attributes that I talked about, both the ceiling to sprinkler distance and the aisle width that's approved for sprinklers, have an impact both on the flexibility during installation as well as the amount of warehouse capacity available based on the fire protection scheme. And these are two fairly significant attributes when it comes to using and selecting ESFR protection schemes for warehouse protection. And with that, I will open it up to any questions.
Great. Thanks, Manny. So we do have some time for some questions, so let's go ahead and get started. The first question we have here, what is the first question? So this is a general question, and not necessarily the scope of this presentation, but could you maybe briefly speak on what prompted the change to NFPA 13 in regards to the revisions to the storage chapter by sprinkler type?
Well, thankfully, I'll try to answer this one quickly. But essentially, what the feedback that the NFPA committee has got from people using the book was that the book was becoming very challenging, and that to design sprinkler systems using NFPA 13 required readers to bounce back and forth between chapters. And what they tried to accomplish was an approach where things would progress. So you would go, from chapters, or the early chapters to the later chapters based on the occupancy or storage applications. And so it tried to minimize the bouncing around that the user of the book would have, and also really wanted to use the book or in a manner that people actually that was paralleling the path of how people design fire sprinkler systems. So it wasn't as people think, just to make everybody's life more miserable, because everybody have been using NFPA 13 and have they know chapter and verse of how to install sprinklers, and now every single chapter and verse has essentially been changed. So what the goal wasn't to make life more miserable for people, although I'm certainly there's a lot of angst among users of the 2019 edition. And it's certainly going to take time for people to get used to it and find the things that they're used to finding. A bit of insight as to the mindset of what we're trying to do. The goal is, in the long run, make it easier. So even though you've been doing this, some of you may have been doing this for 30 years, chances are you're not going to be doing this for another 30 years. I would hope not. And then as things evolve, the use of the book, the use of the standard will actually, the revision to the standard will actually make things easier in the long run. There's certainly going to be there are growing pains, undoubtedly growing pains with this. But it will, once you get used to it, and I've been adjusting myself, obviously, and actually, I particularly like the way the storage sprinklers are presented, in the fact that I can go to the type of sprinkler and then figure out what are the best protection schemes based on the type of sprinkler. I think, for myself, I think that makes things cleaner and easier to find. But that's just my view.
Great.
It's a great question, because I get that a lot.
Thanks, Manny. So one quick comment, Manny, your audio seems to be coming in and out. I'm not sure if it's your headset connection, maybe. It's just here or there, so we are missing a couple of words. It's not terrible, but just wanted to bring that to your attention.
Okay.
The next question we have here is, and a couple of questions in regards to the distance between the top of storage. Could you comment on what that allowable distance is and how that changes depending on the different types of ESFR sprinklers and their K factors?
Yeah, so those that are approved by the NFPA schemes, I believe, off the top of my head, I don't know exactly, but I believe the minimum distance that's allowed for ESFR sprinklers is 3 feet, and I believe that's also the distance that's currently shown in FM 2.0 for storage sprinkler applications. I have, just like all of you who are designing things, to verify, you would need to verify exactly if there are any unique schemes that have something where the requirement is greater than 3 feet. But off the top of my head, I would say most are 3 feet, if not all. But don't design something based on what I said. Please look in the document that you're using to validate that.
Great. The next question we have here is, what is the maximum storage or ceiling height ESFR sprinklers are currently listed or approved for?
Should I back up and repeat my presentation? No.
Yep.
So ESFR sprinklers, so within NFPA, if you go to NFPA 13, the highest ceiling heights that ESFR sprinklers are approved for is 45 feet. There is a UL specific application listing where certain ESFR sprinklers are listed for 48-foot ceiling application. And now within FM 8-9, there are ESFR sprinklers that are approved up to 55-foot of storage, 55-foot ceiling with the 50 feet of storage.
Great. The next question we have.
As far as the highest ceiling height is 55 feet. That's the easy question.
Gotcha. Thanks.
Easy answer. Sorry.
The next question we have here is, doesn't the customer choose the number of racks in the aisle width? And if that's the case, then the designer just has to work with the scheme they are given?
That may be the case. The warehouse owner or operator who are putting the warehouse, they might be, they certainly are determining what type of racking system they want to use, and the aisle widths. However, but one, you have to make sure that the aisle width they want to use is something that can be used with the sprinkler you're selected. So, for instance, if the building owner said, I want to have something, with a 3-foot aisle, obviously you can't have something with a 3-foot aisle. Well, I guess you could be a multi-row rack scheme as opposed to a double row rack scheme. But so it is important to get feedback. It works both ways. You want to make sure that the aisle width that the owner gives you is compatible with the sprinkler that you're designing. Obviously, you can't go lower than what's approved. And if you have opportunities to go back to the warehouse operator and say, hey, if we use this sprinkler, you might be able to reduce that aisle width and put more racks in your warehouse. So, there's opportunities where people who are designing systems might be able to add some value to the warehouse operator by giving them different options relative to the aisle width. And you know, if you're the contractor and going to be installing these things, certainly you want to pick the sprinklers that's going to give you the most flexibility with installation on the ceiling as well. You know, my point with the presentation is just to make you aware that there are differences, and with those differences come opportunities that offer benefits to people who are running warehouses and people who are installing sprinkler systems within warehouses.
Great. Next question we have here is, for CMDA and CMSA, why are K8 sprinklers not included? And why are K25.2 extended coverage used in this application?
So, well, first of all, so with regards to 8 K-factor sprinklers, I think there's been enough fire testing done with sprinkler K-factors less than 11 in warehouse storage applications and demonstrated not very good fire protection. So if you look at what's in NFPA 13 and what's in the FM data sheets, typical storage sprinklers start at 11 K-factor. That's based on fire testing in comparison 11 K-factor performance to fire tests that were conducted with both 8 and 5.6 K-factor. The problem with those smaller K-factor in warehouse fires, with very strong fires, plumes that are developed, the 5.6 and 8 K-factors do not have very strong spray patterns in terms of being able to penetrate that fire. Those smaller K-factors result in smaller droplets, which makes skipping, the phenomenon of skipping that I talked about, very, very prevalent. And fire testing using those small K-factors have, operated. Sometimes they've operated like all the sprinklers on the test ceiling, 50 or 60 sprinklers. And so the protection schemes for storage applications have moved away from smaller K-factors and looking at K-factors that are 11 and above. With regards to the EC25 sprinklers, so they're upright and pendant extended coverage K25.2 sprinklers that are available. They're CMSA type sprinklers. They certainly can be used. My presentations, focus more on the ESFR applications. I believe the K25, EC25s are limited to either 40, 35, I think 35-foot ceilings. I have to go back depending on the commodity classification again. So they don't go as high as, they might go to 40. I'm sorry, 40 feet, but they certainly don't go as high as ESFR sprinklers. But they're for their approvals, they're approved at the minimum widths. The upright sprinklers, can be installed with deflectors, I think 6 inches to 12 inches below the ceiling. But my presentation was focusing on ESFRs, but certainly EC25.2 K-factor sprinklers that are available are good solutions for the protection schemes that they're approved for.
Great, thanks, Manny. So we're approaching the top of the hour, and we're going to have time for one more question. And Manny, I want to preface this as I don't think that this question is, again, within the scope of this presentation, but we've gotten quite a number of people asking about this. So I did just want to throw it to you. But there were a number of questions just asking if you have could make any comment or aware of any information in regards to the recent Redlands warehouse fire. Again, don't expect you to answer that necessarily, but if you have anything you could comment on, I think the attendees would be grateful for it.
Yeah, I've reached, I don't know anything about the fire other than what I read on some of the news websites, that there obviously was a fire out there in California in an Amazon warehouse that I believe was operated by a third party, not necessarily Amazon itself. And that, I don't know anything more. I have not received any information. I don't know what type of sprinkler system, if it had a sprinkler system, what type of sprinkler system and type of sprinkler. So like a lot of people probably on this call, we're all anxious to hear about, what actually happened at that facility. I haven't received any details, and I'm hoping to, obviously that, has a potential impact on our industry. I recall a quote by somebody in the article, I don't know who was the fire chief, indicated that, the facility had the latest fire protection technology. I don't know what that means, but so we're all, like everyone else, I'm very interested in hoping that, whatever whatever went wrong is something that we can certainly correct and make sure it doesn't happen again.
Great. Thank you so much, Manny. There are a few other questions, but we'll go ahead and just forward that to you and ask that you just respond to them individually. So thanks again for everyone for attending today's webinar. Thanks again to Manny and Johnson Controls for providing this this webinar today. So thanks.
Thank you, everybody. Have a great day.